Hello everyone, good morning to you all. I hope that I am audible to everyone. Am I audible to everyone? Is my voice is audible to everyone? One student replied, "Good morning, sir." I want a reply from all of you whether I am audible. Okay. One student has replied that, "Yes, sir, you are audible." So, my next question to you is whether my computer screen is visible to all of you. Whether my computer screen is visible to all of you. Whether my computer screen is visible to all of you. Is my computer screen is visible? Yes, that's to one student has replied, "Yes, sir, it is visible." Thank you all for joining this lecture series on theory of computation, get related problem discussion regarding the subject ESP5, and today we are discussing module 3, which is on push down automata, context free grammar, context free language. We are observing the first problem here. It says that consider the NPDA where capital Q is the set of states, contains three set of states Q0, Q1 and Q2. Capital sigma is the input alphabet, which are 0 and 1. Capital gamma is the stack alphabet, which are 0, 1 and initial stack symbol. This is denoted as initial stack symbol. Small delta represents the state transition function. Small q0 represents the initial state, and this symbol represents the initial stack symbol, and capital F, which is q2, represents the set of accepting states. We have observed that the non-deterministic push-down automata works as follows, where q0 is the initial state indicated by incoming arrow. If in a q0 state I give 1, then I push 1 in the stack. If at state q0 I give 1, then I shall push 1 to the stack. If at state q0 I give 0, then I push 0 into the stack. It may possible that for 0, 1 or epsilon I may transit to q0 to q1. Here capital Z represent zeta. Capital Z represents zeta, which represents the operation of the PDA. At q1 state, if I give 0, then what happened? If I give 0, then I popped 1 from the stack. And if I give 1, then I pop. If I give 1, then I pop 0 from the stack. Okay. And at Q0, if I give epsilon, then all the elements of the stack which is pushed earlier will be popped, and only the initial stack symbol left in the stack, and we reach to final state, that is Q2. So it is important to observe that so it is important to observe that it is important to observe that this particular PDA accept all the string x0 x to the power r. It accepts all the string which are of the form x1 x to the power r, or x epsilon x to the power r, which is can be written as x to the power r. Whereas I can say that x to the power r is the reverse of the 1's complement of x. That means if x is 1 0, if x is 1 0 1 1 0 1 1 0 0, this is my string, then I can assume that this is my x, this is 0. And what will be the x to the power r? X to the power r will be the 1's complement of 1 0 1 1 0. Its 1 complement is 0 1 0 0 1, and its reverse is 1 0 0 1 0. I repeat, 1 0 0 1 0, that is the reverse. So x to the power r is 1 0 0 1 0, that is the reverse. In our question, it is said that which one of the following sequence must follow the string 1 0 1 1 0 0. So our string is 1 0 1 1 0 0. So needless to say, this 1 0 1 1 0 is my x, and this 0 remain intact, and we need to calculate x to the power r, which is 1 0 which we have calculated as 1 0 0 1 0, 1 0 0 1 0, we have calculated that. So the correct option is option B. So again I am repeating this word, this PDA is accepting all the strings of the form x0 x to the power r, x1 x to the power r, x epsilon x to the power r can be written as x to the power r, where x to the power r is the reverse of the 1's complement of x. If my given string is 1 0 1 1 0 0, then I can assume that 1 0 1 1 0 can be x. then x is 10110, 0 remains intact. We need to calculate x to the power r. So x to the power r is the ones complement and reverse of the string, which is nothing but 10010. We have calculated it. So the correct option is 10010. That's the correct option. Now this string is accepted by the automaton. So very easy to understand this thing, why this string is accepted. Now come to this portion. 10110, then 0, this is x, and x to the power r is 10010, that is x to the power r. Now why it is accepted? When I push enter 1, I push 1 into the stack. When I enter 0, I push 0 into the stack. When I enter 1, I push 1 into the stack according to this rule. I give 1, push 1. I give 0, push 0. Then I give another 1. Then I enter into the stack. Then I give another 0. Then it will be entered into the stack. So x is completed. After that there exists a 0. For that 0 I need to transit from Q0 to Q1. So now I am in state Q1. But at state Q1, if I receive 1, I need to pop 0. So I receive 1. So I popped 0 from the stack. Needless to say, I have started from the initial stack symbol, which is this one. Again I receive 0. I receive 0, so I pop 1, because you see, if I receive 0, I pop 1. I receive 0, I pop 1. I receive 0, again I pop 1. I receive 1, I naturally pop 0. I receive 0, so I naturally pop 1. I have started the stack from the initial stack symbol, which is this one, and I have, after pushing and popping operation is completed, once again I come back to the initial stack symbol. That means this particular string is accepted by the PDA. So if you have any kind of question regarding this particular explanation of the problem, then you are advised to ask. All the students are advised to ask question if there is any regarding question number 1 comes in GATE examination earlier at 2015. Please ask your question if you have any doubt. Please ask your question if you have any doubt regarding question number 1. Okay, students has replied, no question sir. So we can go to the next problem. This problem says that there are three types of language: L1, L2, L3. Now, which of this language is context free? I would like to take I would like to advise you to take the and snapshot of this problem, and please solve this problem at your home. It says that L1 is equal to a to the power m, b to the power n, a to the power n, b to the power m. L2 is equal to a to the power n, m, b to the power n, a to the power m, b to the power n, and L3 is equal to a to the power m, b to the power n, where m is equal to 2n plus 1. Please solve these problems. You have already solved this type of similar problems earlier. Please solve the problem once again and try to find it out whether these languages are context free or not context free. Please take the snapshot of the screen so that you can able to perform your operation. Next problem, you should take the snapshot of the next problem also. It says that for any two languages L1 and L2 such that L1 is context free and L2 is recursive enumerable but not recursive, which of the following is are necessarily true? First, L1 complement is recursive. Next, L2 complement is recursive. Next, L1 complement is context free. And 4, L1 complement union L2 complement is recursive enumerable. In order to solve this problem, you need to understand the closure property of recursive language, recursive enumerable language, and context free language, so that you can able to solve your answer. So L1 complement, L2 complement, L1 complement. So with these 4 options you need to choose a particular option. It is already said that L1 is context free and L2 is recursive enumerable. You have 4 options. Option A says 1 is correct. Option B says 3 is correct. Option C says 3 and 4 is correct, and option D says 1 and 4 is correct. Please take the snapshot of this problem and solve this problem at your home. Please take the snapshot of this problem. Please take the snapshot of this problem and solve this problem at your home. Please solve this problem at your home. Now, let us come to the next question. Consider the following context free grammar. G1 is equal to S G1 is equal to S G1 is equal to, so G1 says that it produces S. So I replace this S. If I replace this S by B, then it will be small a capital B. If I replace this B by another B, then I can found that in this particular string present in the language, we have equal number of A and equal number of b. Let me assume the number of a is represented by m and number of b is represented by n. Next, if S produces b, then it will be either b or it will be either b, b. In this way it will continue up to infinitely. So from this particular string we can conclude thus grammar produce at least one b that should be produced by this grammar, and up to infinity, up to infinite b we can produce. So minimum 1 b can be produced, minimum number of b is 1, maximum number of b is infinity. That we understand. Similarly, if S produces AS, again this S produces AS, in this way it will continue. Ultimately, after infinite number of times, okay, this last S has to be replaced by a single b or multiple b. So, conclusion is minimum number of a is 0, because you see, if we are considering only b, there is no a, so minimum number of a is 0, whereas maximum number of a is infinity. So it is clear that m should be less than equal to 0, because m represent number of a, and n should be greater than 0, because n represents the number of p. So our correct grammar is naturally this one, a to the power m, b to the power n, where m less than equal to 0 and n greater than 0. N greater than 0 indicates that minimum number of b is 1 and maximum number is infinity. M less than equal to 0 indicates that minimum number is 0, maximum number is infinity. Now come to grammar number 2. Grammar 2 says that S produces this one. Okay. So at least one A should be produced. Sorry, at least, yes, at least one A should be produced. And it also says that S produces B, small b, capital B. So at least one B has to be produced. If I at least one B has to be produced, okay, at least one B has to be produced. Okay, S produces small a, capital A. If I consider it, if I replace this A, sorry, my mistake, S produces A, capital A. So this A can be replaced by another A, that can be possible, and this last A can be replaced by epsilon, so it will be A, simple A, that we can able to produce. Or if I consider this rule, S produces A, small a capital A, and I replace this capital A by suppose capital B, then it will be A B capital B, then it will be A B epsilon, then it will be A B. Okay, if I so if I take this rule, S produces A capital A, so small a cap is if replaced by capital B, and B can also be epsilon. So at least one A, we are observing that at least one A is basically can be produced. At least one single A can be produced, and single B can also be produced. How? Because if S produces small b capital B, and I replace this B by say epsilon, then small b can be produced. So one B is produced with no A, that is also possible. Single A can be produced with no B, that is also possible. Okay. So I can say that minimum number of A, which is represented by M, should be either 0 and max to max infinity, and maximum number of B should be either 0 or infinity, that is also possible. Minimum number of, so let me correct it, so it should be less than equal to. So the correct option is minimum number of A should be less than equal to 0, should be greater than equal to 0, because minimum number of A is 0, maximum is infinity, and number of A is represented by M. Why minimum number of A is 0? Because whenever we take this rule, we observe that there is no A, so minimum number of A is 0. Why? Next, minimum number of B is should be less than equal to 0. Why it is that? Because we observe that whenever I take this rule, particular rule, there is no B, there is no B, so I can consider the minimum number of B is basically 0, maximum is infinity, as because number of B is represented by n, so n should be greater than equal to 0. So the correct option is this one, A to the power m, B to the power n, where A is repeated m times, B is repeated n times, and minimum number of A is 0, maximum number of A is infinity, and minimum number of B represented by n is 0, and maximum is infinity. So our correct option is D. So we are about to select this option. Now if you have any doubt, you can ask. There is a mistake in the problem. In the fourth option, there should be greater than equal to sign. It is missed out somehow. Please correct it on yourself. No, the answer is the answer of the first question is B. Answer of the second question is D, because I have already corrected it. Okay, the by mistake somehow the equal to sign is not there in the D option. Please make it correct on yourself. Why D option is correct, I have already said that. Now if you have any kind of question, you can ask. Sir, will you please explain the second grammar once? Okay, obviously, sure, for sure I shall explain. We are observing that S produces small a capital A, if I replace this A by capital B, as you can see, A can be replaced by capital B. Okay. Now this B can be replaced by epsilon also. So if I replace this epsilon, then it will be single A and there will be no B. In this particular string there will be no B. So I can conclude from there that minimum number of B can be 0. Next, if I take this grammar, S produces say small b capital B, and I replace this capital B by epsilon, then it will be single B, there will be no A is missing. So I can conclude that minimum number of A which is represented by M can be 0. Whereas we are observing that S produces A capital A. If I replace this capital A by again AA, if I replace this capital A again by AA, in this way if I continue this up to infinite times, I can observe that I have infinite number of A's, and last A I can replace it by epsilon. So there are how many in A's are present there? There are infinite number of A's is present there. So I can conclude that the maximum number of A represented by M can be infinity. So needless to say, M should be greater than equal to 0, because minimum value is 0, maximum value is infinity. Next is, we are observing that the value of S produces small b capital B. If I replace this B by once again small b capital B, and I continue this up to infinite times, I can find that I have infinite number of B's at my disposal in my string, and the last B I replaced is by epsilon. So how many B's are present there? Infinity. How many A's are present there? 0. So this is allowed. So number of B's is represented by M. So I can say that maximum number of N is infinity, minimum is 0. If I consider this case, or this case, maximum number of N is 0, maximum number of N minimum number of N is 0. So I can conclude that N should be greater than equal to 0. Greater than equal to 0 means minimum value 0, maximum value 1. So my correct option is option D. In option D, less than equal to sign is missing, please replace it. So the correct option is option D. Next, take the question once again, whether, and let me ask you whether it is clear to you or not. Is it clear to you? Is that particular logic is clear to you or not? Okay, it is clear. So without wasting time, let's go to the next question. Please take the snapshot of this question, and it has come in 2016. It is given as home task. Okay. A student wrote two context-free grammar G1 and G2 for generating a single C like array declaration. The dimension of the array is at least 1. For example, int a 10, 10 3. So the grammar uses D as start symbol and uses 6 terminal symbol int id num. The grammar G1 is as your disposal. The grammar G2 is also as at your disposal. Now you need to say that which of the grammars correctly generate the declaration mentioned above. Both G1 and G2, only G1, only G2, neither G1 nor G2. So which one is the correct grammar? Please take the snapshot of this slide and solve this problem at your home. Please take the snapshot of this slide and solve this problem at your home. Take the snapshot of Problem number 6 also, it says that consider the transition diagram of a PDA given 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 below with the input alphabet big sigma equal to a comma b. That means input alphabet accepts a b. Stack alphabet set is represented by big gamma, and it is capital X and capital Z. Z stands for zeta, and Z is the initial stack symbol. Let capital L denotes the language accepted by the PDA. The PDA is given to you. This is initial state and also final state. And if I give a single B, then I can transit to state number 2. If I give B, then I can stay at state number 2. If I give epsilon, then I can go to the final state. Which one of the following is true? There are 4 options. L is equal to a to the power n, b to the power n, when n greater than equal to 0. And it is not accepted by any finite automata. That is an option. L is equal to a to the power n, where n greater than equal to 0. Union a to the power n, b to the power n, n greater than equal to 0. So you need to choose the correct option between these 4 options. Now come to our next problem of discussion, that is basically question number 3. It is said that we need to identify the language generated by the following grammar, where S is the start variable. So you always start from S. So S produces capital X, capital Y. Okay. So if I consider this, if I replace this capital X by small a, if I replace this capital X by small a, then I am left with only one non-terminal, that is capital Y. Capital Y can also be replaced by epsilon. So I can say that S produces single a, that is allowed. Next is S produces capital X, capital Y. If I replace this capital X by small a, as because I have already said that S produces small a, so at least one a should be produced. At least one a should be produced. So if I replace this, X produces xy, then X can be replaced by so a, and Y can be replaced by B. So at least one a should be produced. So Y can be, if I replace this Y by a y b, then the B comes. But we observe that number of A is always greater than number of B. So we can come to conclusion, if number of A is represented by M, if number of A is represented by M, and M, then we can say that minimum, we can say that minimum number of minimum number of A should be at least 1 and maximum number of A is infinity. Whereas minimum, if n denotes the number of B, n denotes the number of B, minimum number of B can be 0, because I see there, look at this string, there is no B, there is only A, so that is 0, and maximum number of B is infinity. Maximum number of B is infinity. So I can say that always the number of A is greater than number of B. I can conclude that always the number of A is greater than the number of B. I can able to say that. Okay, so which of the grammar is basically true? It is already said that the number of A denoted by M is always greater than number of B denoted by N. So M must be greater than equal to N. So naturally option A, where M greater than equal to N, that is already deleted. Second option is already there, M greater than equal to N, so it is also deleted. Now it leaves me with the last two options, C and D. Now in D option, N should be greater than 0, not equal to 0, but here we are observing N can be 0. So naturally option D is deleted, so correct option that is left with us is option C, because in option C it is said that number of A can be greater than number of B and number of B should be at least 0. So that is why this is the correct option. That is why this is the correct option. So that is the explanation about this particular question. Now let's come to the next question, which is in GATE 2018. Now if you have any doubts regarding 2017 solution, please ask. If you have any doubts regarding 2017 solution, you can please ask. No doubts, students replied, no doubts. So I come to our next question, that is, which has come at GATE 2018. We can able to see that at the first grammar, look at the first grammar, A to the power M. Look at the first grammar, A to the power M, B to the power N, C to the power P, D to the power Q, where M plus P, number of A and number of B should be equal to number of C and number of D, where all of them, minimum number of all of them can be 0 and maximum is infinity. So if I consider this string A, B, C, D, suppose I take single one of them. So this is my stack. Stack is started from the initial stack symbol, which is this one. So I received A, suppose I enter X, pushed X into the stack. I received B, again I pushed X into the stack. Okay, I receive B, then I pop X from the stack. I pop X from the stack. I receive C, I push suppose Y into the stack. I receive D, I pop Y from the stack. So what happens is that stack becomes empty. Stack becomes empty. I receive A, I push X. I receive B, I pop X. Again stack is empty. I receive C, I enter X, Y into the stack. I receive D, I pop Y from the stack. So stacks is now, after the scanning D, the stack is empty. There is no element in the stack. So from where I have started, I have come once again to that. That is the initial stack symbol. That is clearly said that this particular language is accepted by PDA. We know that if any language is accepted by PDA, it is basically a context free language. So option 1 is naturally a CFL. Come to option number 2. A to the power m, B to the power n, C to the power p, D to the power q, where m equal to n, that means number of A and number of B should be equal, and number of P and number of Q should be equal. Okay. So how I can able to tackle this, where all of them minimum value is 0. Suppose I accept this string A, B, C, D. I want to accept this string A, B, C, D. So I have started from my stack, initial stack symbol. I have started from that. Okay. So we can observe that the string is basically AB or CD or ABCD or double A double B CD or AB CC DD. Look at that. Number of A and number of B is equal. Number of C and number of D is equal. Look at that, number of C is 0, number of D is also 0. Look at that, number of A is also 0, number of B is also 0. So I am considering this particular string. I am considering this particular string. Okay, I am considering this particular string. How I can able to accept it? It can be accepted. It can be accepted. How it can be accepted? Very simple, in the same way. Basically it can be accepted. Whenever I scan A, I push X into the stack, and whenever I scan B, I pop an X from the stack. So now stack is empty. Again I scan C, I popped Y into the stack. Again I scan D, I popped Y from the stack. So now stack has started from initial stack symbol, and after scanning all the string, all the character present in the string, I have come once again to the initial stack symbol. That means this language L2 is accepted by the, this language 2 is accepted by the PDA. That means it is basically a context free language. Option 3. Option 3 is not in the PDA. Why? Because look at that, number of m, number of n and number of p, they are equal, but p and q are not equal. So what happens is that A, this is denote number of A, B, this is denote number of B, say single C, this is denotes number of C, and D is P and Q is not equal. So D should not be 1, D should be 2 or 0. Okay, D should be 2 or 0. If D is 2, then what happens? Look at that, I have started from the initial stack symbol, this one. For first A, I have pushed X into the stack, and for second B, I have popped X from the stack. For C, I have pushed Y into the stack, and for this D I can pop Y from the stack, but for the last D there is no element to push on pop. So there is no element to push and pop. So I can say that there is still one D is left in the strings to scan. So that is why a single D is still left to be scanned. That is why I can say that yes, it is not accepted. Next is Mn equal to P plus Q. If I Mn is equal to P plus Q, so same logic is here, as because basically these types of computations, if we do these types of condition checking operations, that cannot be done with the help of the PDA. So naturally option 4 is not also be possible with the help of language 4 is not also accepted by the PDA. So option 3 is not accepted, option 2 through 4 is not accepted, only option 1 and 2 is accepted. So correct option is option B. Take the snapshot of this problem. This has come at 18. You should solve it at your home. Okay. Context free grammar can be used to specify both lexical and syntax rules. This problem is related to the compiler design. So you can also solve this problem in the 7th semester also, after 7th semester also, because this problem is related to compiler design. So you can leave this problem also. Next is last problem. It is said that which one of the following language is not context free? A to the power n, b to the power I. So we are observing that option first is a to the power n, b to the power I. Okay, it is basically CFL because we have union of 3 CFLs, and CFLs are closed under union properties. Look at that, a to the power n, b to the power I, where I is n, 3n, 5n. So that means a to the power n, b to the power n union, a to the power n, b to the power 3n union, a to the power n, b to the power 5n. As because a to the power n, b to the power n, this is basically CFL, a to the power n, b to the power 3n, this is in CFL, a to the power n, b to the power 5n, this is in CFL. All CFLs are closed under union. Hence I can say that option A is also context free language. Option B is not context free language because you can identify strings of the given language using only one stack, but we need at least 2 stacks. There is alternate string matching, which is not possible using only one stack. So this is context sensitive language but not context free. So a to the power n, w to the power r, b to the power n, it is not basically the context free language, because to check whether this w and this w to the power r, they have pushed and popped properly, we need a stack. And similarly a to the power number of a pushed into the stack and number of, for every number of b, one of the a is popped from the stack, we need to check another stack. So 2 stacks is needed, which is not possible in case of a PDA. PDA use only one stack, cannot use 2 stacks. So I require 2 stacks, one for checking w and w to the power r, okay, and another for checking a to the power n and b to the power n. That is checking, that is for checking. W to the power r is already in PDA, because you see A, B, C. Next, W to the power r will be the reverse of the string, that is C, B, A, the reverse of the string. I scan A, I push X into the stack. I scan B, I pushed X into the stack. I scan C, I pushed X into the stack. Okay. Again I scan C. For every C, I can push XC from the stack. I push this X. I scan B, I push popped B. I scan A, I popped A. So stack is starting from the empty and it has come back once again to that. So it is accepted. Next is W A to the power n B to the power. Now this is interesting. A to the power n B to the power n is between W and W to the power. After W to the power r, there will be nothing like that. So A to the power n B to the power n is in between them. They are basically acting as a separator. So needless to say, A, B, C, then we have A, B, then we have C, B, A. Let's see whether it is accepted or not. For X, I have pushed X. For B, I have pushed. For X, I suppose I have pushed A. For B, I have suppose pushed B. For C, I have suppose pushed C. For A, I have pushed X. For B, I have to pop X. So X is being popped. For this particular C, I have to pop C. Now C is the topmost element, I popped it. For B, I have to pop the B. Now B is the topmost element, I popped it. For A, I have to pop an A. So A is the topmost element, I have popped it. The stack is empty. So it is accepted. So D is accepted, C is accepted, A is accepted, only B is not accepted. Hence, I can say that B is not context free. With this, I am ending my lecture here. If you have any kind of doubts, do not hesitate, you can ask. Lots of context free languages are basically the context sensitive languages as well. Whenever there are two stacks are needed, that language cannot be context free because two stacks are not allowed in PDA. As simple as that. Sir, please explain the last option. Last option is basically A, B, C. For A, I push A into the stack. B, I push B into the stack. For C, I push C into the stack. Then I have A to the power n, B to the power n. Say there is only one A, only one B. So for middle part, that is A to the power n, B to the power n, for every A, I push X into the stack. For every B, I popped A from the stack. And then C, B, A. For every C, I pushed C from the stack. For every B, I pushed B from the stack. For every A, I pushed A from the stack. Now the stack becomes empty. So that means stack empty means it is accepted by the PDA. If it is accepted by PDA, it is basically in the it is basically a context free language. So no question from your end. So I am ending my lecture here. We shall meet once again in the next week.